We are down at the Meadows shops with Greg Cohn and the 1908 Matheson automobile engine, and he's recently rigged up a motor to make it rotate. And you're going to tell us a little bit about what we're going to look at. Why are you doing this, Greg?
So that I can adjust and experiment with the proper electrics that will be applied to this. So this is just a mechanical action.
Greg is going to explain to us what his dial tells him that's on the front end of the camshaft.
Okay, make and break system has a lot of adjustments. And what I've done here is I have tried to use a homemade protractor to time the opening and closing of the individual hammers, because there's an adjustment for when they close. There's also an adjustment for the gap between the hammer and the anvil, and that gives you a dwell, an instant, how long the electricity is allowed to flow. And the reason I'm going through all this is I want them all alike, timed individually, 90 degrees apart, and also the same amount of dwell that they're closed. So I'm trying to find out how to do this physically with a protractor and also electrically with meters.
Okay, and for simplicity's sake, again, I'll repeat. The anvil and the hammer are located inside the cylinder,
in the combustion
above
chamber.
the piston in the combustion chamber.
So,
And make and break is the hammer comes down to the anvil, and when they come apart, we get a spark.
that's right.
A very low voltage spark.
But a fat spark.
I'm sorry, sir?
A fat spark.
A good fat, low voltage spark.
Yes.
And it, you don't know how long that's going to last, or the dwell, the time that it's going to
No,
make?
but I want them all the same. So
Okay.
I need to invent a way of doing that.
Okay, I wonder if anybody did this back in the old days.
Probably not with this much care. The rotating cam comes by and kicks the trigger, which then operates the point inside the combustion chamber.
And that's called make and break.
Make and break. This is the anvil. That contact will have electricity applied to it. This is the hammer. That's also the ground to complete the circuit.
And when they come apart, they make a spark.
Right.
And that ignites the mixture. And you rigged this up out of a sewing machine motor, right?
Yes, it's variable speed. And right now we are running 350 RPM. So double that for crankshaft speed. About 700 RPM, which is within its operating range, I'm sure.
I wish I could do this justice. Can you reduce the speed any?
I can try.
Now I can almost follow the action.
That's 200
200. That's
RPM.
You slowed it down 150 RPM. And we can see the arm striking the cam, or is that not a cam? That's a blade,
that
isn't it?
blade is I would call it a tangential cam or something. I don't know what it is.
Very interesting. What is this piece in here?
This supplies the electrical current to that anvil.
So if you had a battery hooked up to that thing, I could have felt 6 or 7 volts because it's low voltage, right?
Very low voltage.
Very little voltage. That's why we have to use make and break. No coil.
Well,
No spark plug.
it will have a simple coil. Kind of fun, huh?
One more thing, you mentioned earlier on that they were proud of their work, and that's why you've taken the time to polish these fittings and things. And I see that big old magneto down there. That must be a water pump in front of it.
Yes, water pump.
Thank you, Greg.
Thank you, Jim.